Hi, I'm Michelle Segrest, and welcome to the Factory of the Future podcast.
This podcast is inspired by my 3-volume book series on the evolution of modern manufacturing. Each episode features engaging conversations with game-changing experts discussing the processes and innovations that are changing the landscape of modern manufacturing. Thank you so much for listening. Please do me a favor and leave me a 5-star rating on iTunes and take just a couple of seconds to leave a review. And then go ahead and hit that subscribe button right now so you don't miss a single episode. Today, I am so happy and excited to welcome Professor Robert Jackson as my expert guest. Professor Jackson is a leader in tribology, contact, and lubrication engineering research, and he has more than 100 refereed journal publications. He also has more than 140 conference papers and presentations, 3 book chapters, and 13 invited seminars to various organizations. But that's not all. Professor Jackson was also awarded the 2011 ASME Burt L. Newkirk Award for notable contributions to the field of tribology. This is in addition to receiving 2 international awards for research publications. In 2009, he received the IEEE Erie Schobert Prize Paper Award at the Home Conference on Electrical Contacts. And in 2009, he won the STLE Hunt Award for the best paper published in the field of lubrication. These are major awards from 3 different societies. In February 2012, Professor Jackson successfully obtained approval for a new undergraduate minor in tribology at Auburn University. This truly multidisciplinary minor could influence education in the area of tribology and engineering for many years to come. Since arriving at Auburn University, Professor Jackson has established the very successful multi-scale tribology laboratory. Prior to this, there was relatively little history of tribology at Auburn. He has helped to secure many grants for projects ranging from fundamental tribology studies to the study of high-power electrical connectors for hybrid and electrical vehicles and researching the properties of articular cartilage. But what is tribology and how does it influence industry and the future of manufacturing? Today, we're going to find out. Now, full disclosure, I'm an Auburn graduate, a big-time Auburn fan, and both of my children are Auburn graduates. So, of course, I'm really proud that Auburn is the leader in this field. About 4 years ago, I met Professor Jackson when I went to Auburn to interview him for an article that originally appeared in Efficient Plant magazine. It explored this one-of-a-kind program at Auburn University that's helping to develop manufacturing engineers with hands-on experience that translates directly to real-world jobs, and as a result, it helps to close the manufacturing skills gap that we talk about all the time on this podcast. I'll include a link to the article in the show notes so that you can go back and read that. Now, at that time, I had no idea what tribology is, but it was so fascinating to learn. I learned that whether it's an airport runway, a manufacturing robot, fluid couplings, power transmission, a tile floor, human joint replacement, hard drive technology, or biomedical equipment, surfaces are in constant contact with each other in the mechanical world. The result is friction and wear. Now, I can tell you what I learned from researching this article and talking with Professor Jackson, but I would rather let you learn it from the expert himself. So now, without any further delay, I'm really excited to welcome Professor Robert Jackson to the podcast. It's great to have you here, Rob.
Thank you for having me on. Looking forward to the conversation.
Yes, I have been really excited about it. We haven't talked about this in many years, so I know a lot more has happened since that time when I researched that article. But I want to start by addressing the most obvious question, and that is, what exactly is tribology for those of us who may not know?
Yeah, it's funny. Now people do know, and even a lot of engineers don't know. Part of my job is getting the word out there about this field because it's very important. Whenever you have 2 surfaces that come into contact, that's tribology. So they could be sliding, it could be a relatively stationary contact, but anytime there's surface of contact, that's the field. And then how you address what's going on. So if there's a lot of friction or surface damage, like wear, how do you address that with lubricants or dry lubricants or coatings or bearings? It's very broad. Unless you really look into the area you're mentioning in your introduction, there's so many applications of it, and I'm learning about new ones every day. So it's important for just about every industry.
Yeah, I find it really interesting that it's not just one thing we're talking about. It's all around us. And even things that you might not think are having this friction or rubbing together, they are.
Yeah. So like even bolts is when you fasten something together with, say, a bolt, if there's any motion over, could be talking at very small scales, can cause slow wear over time. And so that's one other important thing I want to point out is tribology kind of connects larger scales to small scales. So it can connect chemistry to mechanics. That makes it kind of difficult sometimes to study it because it gets very complicated and multidisciplinary because you have to look at areas that were often kind of disconnected, chemistry, physics, the mechanics side of it, large scale mechanics, and try to connect those together.
It's a term that so many people don't know about. Tell us how you got involved in tribology and why this kind of became your thing, your area of expertise.
I'll tell you my story first. See, I took an undergraduate class at Georgia Tech, and it was an elective, technical elective, and it just struck me that this is a very important area, and why have I not heard more about this before now? I talked to the professor who taught the class, and I started doing undergrad research, but later on found a graduate research project, and that's how I got into it. On the other side, I've talked to a lot of people, and a lot of them just kind of, they graduate without knowing what it is, and they go into an industry, and they go into that way because it's very important. So it's kind of interesting that something so important is often not talked about very much in academics.
Do you feel like it's gaining some traction? I know that when we first met several years ago, Auburn was the only school that had this minor, right?
Yeah, as far as I know, we're still the only minor. Tribology research has been around for a while. Quite a few universities that do great tribology graduate level research. Historically, the word tribology comes from this Greek word tribos for rubbing, and that was coined by Peter Jose, and he was tasked by Great Britain to look at how much loss there is in this field of friction and wear. Where does the economic cost? And so he also coined this word, because a lot of times we just change our language and things get more attention. So that's what he was trying to do. It's grown since then, but it goes ups and downs. A lot of things in the research world and academic world kind of depend on hot topics, what's the new thing. It is interesting. A lot of things that come out relate back to tribology, but they don't necessarily call it that. It all ties together eventually.
In the introduction, I gave some examples, and these are examples that you gave me when we worked on the article together. But, when you talk about an airport runway and like a manufacturing robot, I can understand. That's got a lot of moving parts that are all rubbing against each other. But when you say an airport runway or a tile floor, it's harder to envision how that's creating friction.
So when I was hired at Auburn University, the chair of the department then, David Dyer, had a great saying. I'll never forget this, is if it wasn't for friction, all the people of the world would be in the low places of the world. Okay, so and if we think about it, it's true. If it wasn't for friction, we would have no control over where we move, how we can travel, how we can walk. All our travel, all our movement depends on friction between the shoe and the floor, tire and the road. So it's very important to control that friction. If you don't, people can slip and fall. So there's a lot of lawsuits every year with tile friction, or if it's raining and water on the tile and someone falls and the store gets sued. Same thing, with runways. They have to make sure, if it gets icy, that the friction on the runway is enough so that the plane has control when it lands.
Okay, so it's not necessarily like the tile floor is rubbing against itself. It's more that something else comes in contact with it.
Yeah, like a shoe. And there are researchers who they focus on that aspect of tribology, shoe friction, tire friction. Tire friction's a huge area.
Okay, so like a tire, you're driving around in a car and your tire comes in contact with a surface that's slippery or whatever, and maybe is that what causes like hydroplaning or?
Yeah, so that's there's dry friction on the road between the tire and the road, but it's interesting. The only reason there's like two reasons you have grooves on your tire, really. The grooves on your tire are either to push water out of the way, or if you're going off road, or that's a gravel, dirt road, it helps with traction then. Mm-hmm. But if you have a tire on a like asphalt or concrete road, you really don't need those grooves because it's just the rubber contacting the hard surface. So water, it was a big issue that we study in classes I'm teaching right now, lubrication theory, which can explain, if you're driving on the road and You go through a big puddle on the road, maybe it's raining, or maybe there's oil in the water, and you lose solid contact. The friction between your tire and the road can go way down from, 0.1 to like 0.01 or more, and then you could lose control of your car, and that's not good. So that has to also do with anti-lock brake systems, trying to address that issue. Some people in tribology think about we're trying to reduce friction, but there's another side of it where we're trying to increase it or control it. Like brakes. Brakes is another tribology important problem. How do you make brake systems where you have contacts that have a lot of friction but low wear, so they last a long time? And that's hard to do.
Yeah. So just so that I'm understanding this correctly. So the people who study tribology are coming up with solutions to some of those scenarios that you described, like just as something as simple as your shoe slipping on a tile floor. Tribologists are coming up with ways to keep that from happening.
I mean, with some of these things, it's more after the fact, or if someone gets sued or if there's a problem. But
yeah, sure.
And that's part of our struggle as tribologists is sometimes people don't realize it's important until after there's a problem.
I see. The program at Auburn is really important and it's really rare. As you said, you think you're still the only major university out there that has this minor that they offer. But you are actually putting kids into, or they're not kids anymore, they're engineering graduates into hands-on jobs thanks to this tribology program. Tell us a little bit about it. And tell us why it's so important that this is available to these students.
You talk to people in industry, and this is in all engineering, but I think it's particularly critical in tribology. It's hard for them to find anybody graduating that has any knowledge about this area at all. So that said, it's a great opportunity for new graduates to find positions because most people in the industry know it's important and appreciate someone has knowledge of the area. It can be very practical. And so that's why we created the minor. It's trying to, I guess, adjust to the needs of industry, which I think academics should do.
Of course.
Yeah.
And so the tribology program, what kind of courses does it include? Just so we can get a little bit of a vision.
There's some core courses. The core courses, there's some chemistry, a core tribology, like general overview of the whole area. And then there's rheology type course. So tribology is a big industry. We kind of focused on kind of the lubricant side of it because that was the industry that came to us. So it's more the liquid oil lubricant side of things. Those are three of the main core courses, but then we have a list of electives. I'm teaching a course just on lubrication now. There's a course on contact mechanics. We have other chemistry courses. We have some biosystems engineering courses on like hydraulics. Bio-derived fluids is going to be a big area. We hired a new professor recently, Dr. Kyle Schultze, and he's going to be teaching some courses on biotribology. And so hopefully we get some new courses in the minor focusing on that.
One of the really interesting parts of this program is the Tribology Lab. And I mentioned it a little bit in the intro, but I was in this lab. I can remember being there. You took me there, and some of the students were in there showing me some of the different things some of the different projects they get involved with in the lab. Can you tell us about some of those and kind of give the listeners a visual of what that lab is like and why it's so important to these students?
Well, yeah, I think tribology, you can do some engineering with just calculation, but it's very important to do measurements. And tribology is particularly important because friction depends on everything. So it's important to try to replicate your application, your situation as much as possible. And so we try to get the students in the lab to get some hands-on experience making measurements. We haven't been able to do as much recently because of everything going on, but the pandemic. But we have
COVID has affected everything.
Yeah.
But maybe describe like one particular project that was interesting that you don't have to mention names of the kids if you don't want to. Maybe tell us about one. Give us an example.
One that comes to mind that I think was pretty interesting was they did some measurements on clutch paper. So there was a company in Alabama that makes clutches. I won't name them here, but so they provided the clutch paper, and then another company provided.
Hey, what do you mean clutch paper? You're talking about clutch of a car?
Yeah. Or I mean, no, they're actually it's used in a lot of different machines, but yeah, they're definitely in transmissions of cars.
So what is a clutch paper? I don't know what that is. What is that? I don't know anything about
cars. It's a fibrous, it's a composite material. So it's made of multiple things. Mm-hmm. And the reason they do that, it's this hard situation where they're trying to have high friction but low wear. They're trying to make it so the material survives, but it provides a lot of friction. And that's hard to do because usually when you have high friction, you also have a lot of surface damage. Mm-hmm. So they're trying to engineer a way out of that. So that the students, we had this test machine set up where they tested the clutch, the friction in a lubricant at different temperatures, different speeds, trying to look at, how the lubricant affects the friction when these materials engage. It's important in machining components, like in your car, if you're, switching gears.
Mm-hmm.
So it transfers the motion between different components.
So is the point of that kind of experiment to, in a high friction scenario, to prevent it from having too much wear? And that's kind of the goal there?
Yeah, that's one goal. But the goal they were looking at is how the lubricant affected the friction.
Okay.
Because I guess there was concern that some lubricants lowered the friction too much. They worked too good. And so then the clutch didn't work as well. You don't want the clutch to slip. You want the clutch. Once everything comes engaged, you want it to be stationary. You don't want any slip.
I see. I can see how that would be a horrible thing. Okay, so that's really, really interesting. And I remember you telling me that when some of these engineering graduates are going out into the world to find a real world job, a lot of the companies want them to have experience. But a lot of your students, because they have this experience with this Tribology Lab and these hands-on experiments that you're doing with them, that they said, okay, they don't need that kind of real world experience because they have this.
Yeah, and I think just the classes in general.
Yeah, so it's not just the lab, it's the whole program.
I think it's not. Really. The lab does help if they do get some experience, because a lot of the experience is because they're just not exposed to some of these ideas unless they've been in industry.
Well, I can remember talking to some of these students, and some of them didn't come to Auburn because of the tribology program, but they were introduced to it and became interested in it, and then got really interested in that and became their passion. So they went off to careers that focused on that. But now, 4 or 5 years later, after we originally talked, are they now coming because of the tribology program?
Yeah,
Is
honestly,
it starting
I
to
wish,
get that kind of connection? Oh no, you're still having to.
Yeah, I mean, there might be a few. I mean, it's difficult for, when students are looking at college and deciding what career path, things change a lot. So I think honestly, it's like, I think during college, they kind of start realizing what they really want to do as they mature.
Well, I think this is true for just about any profession. When you get to college, that's when you figure out what you want to be when you grow up.
Right.
But I know that a lot of the students that I talked to back then really were passionate about tribology and this program. And
I think it's something everybody, even before, they kind of identify with it, and they know, that's why why we change the oil in our car. People identify with it. But then the technical courses, they don't always get exposed to some of the details of that. And then when they do find that connection, they go, oh, yeah, it is important. Come back to it. Because if someone's really into, we get a lot of people or students who are really interested in cars and working on their car and things like that. And then when they connect to the technical side of it, kind of resonates. One of the other electives in the minor is engines course, which is not all tribology, but part of it is tribology.
Help us, Rob, to understand how tribology relates to manufacturing. I mean, we could take a guess. I mean, when you're talking about manufacturing, you're talking about a lot of moving parts, of course. But how is tribology influencing industry? And maybe you can give us some examples from some different industries, because I know it affects oil and gas, food, and everything from oil and gas to food to chemical. Tribology is relating to all thing different manufacturing industries.
I mean, so there's a lot in that question. So one thing I want to point out at the beginning. So, basically, if any industry has moving parts, there's tribology. Tribology kind of came before industry, or before the Industrial Revolution, if that makes sense.
Yeah, okay.
They do a poll, and every once in a while, this, what's the biggest invention of mankind? And someone might say fire, but usually the wheel is on there. Right.
That's what came to my mind.
Yeah. And the wheel is tribology. You're, instead of fighting friction, dragging something around, you're rolling, which reduces the friction. So, and then, the Industrial Revolution came along, and you might argue part of that was there's some tribology there that enhanced it. Like the oil industry came along at the same time, mineral oil, where they were able to mine it out of the ground. Mm-hmm. And some of that played a role in new lubricants and developing new lubricants. And kind of adapted along with it. Take cars, for instance. Originally, we started using mineral oil in old original cars, and worked okay, but they started figuring out they could put different additives in the lubricant to make it work better. And then as they got better at that, they also were able to design more high power engines and refine things and make better surfaces, machine better surfaces, smoother surfaces. And everything's kind of progressed together in that way. And that's going on now. I think that goes all the way up to modern times with tribology. It's important in the food industry. That's actually advanced a lot in the past 10, 20 years. There's been new regulations with what can be allowed for food grade lubricants.
Mm-hmm.
So they've had to make advancements in that area. There's a lot of environmental concerns nowadays with marine lubricants. So there's a big push to make more biodegradable lubricants and also lubricants that come from biosources like vegetable oils. See other industries.
Are manufacturers actually saying, hey, I need someone who understands tribology to come in and help us be more efficient?
Okay,
is this happening?
Yeah. I have an example of one of our graduates. The paper industry, this is an important one. They have a lot of tribology in their plants. Anytime you have a lot of motion, if you've been to a paper plant, they're taking this pulp and they're putting through all these rollers and moving components and kind of pressing it down into paper. They have people that their job is to maintain the machines, make sure they have longer life, operating optimally. And a lot of that is tribology, making sure the bearings are working and you're relubricating them and you're replacing them when needed and the proper bearings are being used. And so one of our students in the minor, he went into that area and he's now, I don't know exact title, but he's like regional head of maintenance or something for a large paper manufacturer.
That's fantastic. Yeah.
That's something else that gets lost is tribology is important, but it's also, I think, a noble field. Like a lot of the students now want to go into something that's going to have a positive effect on the world.
Right.
And by reducing friction, you're improving how we use our energy that we do have. And also you're making things last longer so we don't have to have as much waste.
We mentioned something in the opening about how tribology is being used with the advancement of electrical cars too.
Yeah, that's a really hot topic right now. They're still working out some of the details, but part of the issue is you have electric current, and sometimes you get current leaking out of the components. And so you have these bearings and they're rolling and there's oil. What happens when the electric current goes through the bearings? Does it have a negative effect on the contact on the oil? So they're trying to figure out some of these issues. Do you make the oil more conductive or less conductive? And some of that is new, but we've had some of these issues in the past with electric motors, but maybe not on this scale because electric vehicles are using a lot of power.
Very interesting. We'll probably be hearing more about that, I think, in the coming years.
I think so. Oh, another point is,
go ahead.
One more point is electrical connectors. They're becoming increasingly important. And so if you have like electrical connectors in your car, or maybe a good example is a charging port, you got to make that port easy for anybody to plug in, even though you're putting high voltages, high amperages through that. And there's some safety issues, but it's hard to get a good electrical contact and also making it easy to hook it up. If that makes sense.
It does make sense. So it has to be a very complex system has to be made simple for the user, for the end user that could be me or you.
Yeah, and it has to be reliable. In those situations, you get sparks, and that can cause damage to the surface.
I hear a lot about arc flash.
Arcings, yeah, you get that's probably a better way to put arcing. And that's another important area. Even when you plug your phone in or your computer, someone's designing all those plugs and connectors to make sure they are reliable.
Fascinating.
Yeah.
It really is all around us, right?
Yeah, it's everywhere.
It really is.
It is, yeah.
Talked about tribology being around since before the Industrial Revolution, and now we are in the fourth Industrial Revolution, and I like to call it Industry 4.0. What do you think are some of the current manufacturing trends? What are you hearing about?
Just in general with Industry 4.0, it's incorporating the information, the communication aspect, so you can tie all your machines and your computers together and optimize things. You've might have heard machine learning,
Of
AI.
course. Yes.
So you can teach the machines to make decisions for you and optimize very quickly. But for that, you need good sensors. You need to make sure that your information, your connections are good, that they're reliable, and that your information they're getting is good, that you're not getting garbage. Because you get any of these systems, these AI systems, you get bad data, you're going to get bad decisions out. But
that's exactly right. Yeah. I mean, the data, having good data is certainly important, but then also knowing what to do with that data. There are now data scientists out there that are specifically in there to interpret the data and advise manufacturers what to do with that data. And okay, here's the data. That's one thing, having it, but knowing what the next step is
Right.
is
And yeah,
something else.
And I think we have to be careful that we don't just look at it as a black box and put all this data in and just make a decision.
Right. Sure.
We have to kind of still know what it means. Tribology has been heading this direction for a long time, being able to measure what's going on in a bearing, in a contact.
Mm-hmm.
It's not easy to do. Is this bearing operating how it's supposed to, or is it going toward a failure? And do we need to take it offline and replace it, or change something, give it more lubricant, or change the lubricant? The other one that I think is really interesting is modeling, because as an academic, we do a lot of this. A really new term now is digital twinning or digital twins.
Digital twin technology. We talk about this a lot on this podcast. I agree with you. This is very big in industry.
But it's hard because I know in tribology, it's a very complicated area, and you're trying to model something and getting a good model that's verified with real data, that it matches what's really going on and is reliable, so that is robust, so that if something changes that you didn't expect and maybe you didn't model, that it predicts the right thing. Making these complex models there's a lot of physics involved, but you can't model everything, so you have to make assumptions. So making sure your assumptions that are good in your model to simplify it so it can be solved, making it fast. So I think that's what they're talking about, is you're trying to make fast decisions. You're trying to replicate the real world with these models.
Do you think this is how tribology plays a role in Industry 4.0? Or are there some other ways as well?
That's one way. If you start putting everything online and start optimizing, it'll probably pick up on the general idea that if you improve the tribology, you're going to improve your efficiency and life of your machines as well. I think it'll kind of highlight some things that maybe it'll help tribologists, because hopefully, the system will also say, hey, you need to look at this and look at what's the best lubricant for this case. Is this the optimal one to use? Are we using too much? Are we using too little?
You said tribology was around since before the Industrial Revolution began, but there's still so many people who don't know what it is. When do you think that the terminology is going to catch up with the history?
Everybody knows it's important. You know that you got to change oil in your car. You know that your shoes wear out.
Mm-hmm.
That around the house, hinges on the door. You know the importance of it, but the value in it. If you go buy a bottle of water and you compare that to the price of a bottle of motor oil, usually right now the water is more expensive than the motor oil, but there's a lot of engineering that goes into that motor oil. I guess not appreciated as much. And knowing that there is a lot of science and engineering that goes into this, and be able to respect that and I think, you're asking about, or is a company going to just do they want to hire someone who just specializes in tribology? I think also just knowing that there's ways to do things better. If you're working somewhere and improve the lubricant that we're using, even though it costs more, maybe that lubricant will reduce friction and wear and actually make us more profitable in the long run. So I guess being able to evaluate the value in it is important.
Are you finding that recruiters and companies that are hiring some of your students right out of college, are they beginning to recognize that this tribology minor is really significant?
Yeah, we've received nothing really but good feedback about it.
So there's people out there that are doing the hiring, they know what it is.
Yeah,
they understand the value. They're not in the dark about what this is.
This is not just tribology, but sometimes when we're teaching subjects, they're still skeptical about, they'll be, we'll never use this, or this is not important. But every once in a while, I'll have a student come back and say, they actually asked me something that you taught in class. And
that has to be wonderful as a teacher.
Yeah. I don't think it happens all the time. Some things, depending on where you get hired, you might not use everything you learned. But
of course,
yeah, it's nice to hear.
That's probably the best thing that could possibly happen to a teacher, right?
Yeah.
I actually used something that you taught me.
Yeah, exactly. I'm doing something right. Yeah.
That's fantastic. I love to talk about my alma mater, Auburn University. I'm so proud to be an Auburn grad. And I know that Auburn also has some other programs that are really preparing young engineers for manufacturing jobs. Can you tell me a little bit about some of those other programs?
Yeah, and this one also ties in, I think, into the Manufacturing 4.0. There's a couple centers at the university. And one's the National Center for Additive Manufacturing Excellence. And so additive manufacturing is you're building things from the ground up instead of removing material when you're machining something. So it's
people love to call it 3D printing. I mean,
3D printing, that's what it is.
It's a little bit more complex than just saying 3D printing.
Yeah.
But That's
It's the
basically
same
what it
thing,
is.
though.
Yeah. Yeah. That's basically what it is.
A huge center here, and there's a lot of work trying to make sure that materials you make this way are as good as conventional ways. And tribology is going to be part of that too, and that some of the biggest issues they have with additive is the surface roughness, the finish. If you have a home printer, like even a polymer printer at home, plastic, and you print something, it's usually pretty rough.
Right.
Whereas if you injection mold it, it's usually much better finish. So that's one issue. How can we address that? And that's definitely related to tribology. And then as they start printing more and more things, eventually they're going to have to use printed parts and moving part and sliding parts where there's going to be contacts. And then they're going to have to worry about, is the friction and wear of these printed parts, how does it behave compared to what we know? And so that's what people are starting to look at. But yeah, this center, they're very successful. It's very impressive that they're printing a lot of metal parts, and those machines are several $1 million each. And so they do a lot of fatigue testing and strength testing. And we've gotten involved with some tribology testing of those parts as well.
Fantastic. All that happening at good old Auburn. It's amazing. Yep. And tell us
then
about the
there's the other
advanced manufacturing. Yeah, the manufacturing center.
Yeah, the other center that it's kind of happened similar time is Interdisciplinary Center for Advanced Manufacturing, which kind of connects this Industry 4.0. So, additive is part of Industry 4.0, but 4.0 is kind of a bigger picture.
Of course, yes.
Incorporating everything, using all the new technology, the new Internet of Things, making things smarter. And they have a facility with top-of-the-line equipment off campus, and they're trying to test some of these things out. Machining processes. One of the big issues is security. If you start tying things online, someone could come in and hack into it, right? You heard of hackers. And if you hack into a system and change what the machine's supposed to be doing, it's like sabotaging product, sabotaging the company. So they're worried about that. And part of that could be tribology too. I was thinking about if you come in and you're making something, machining something, it's automated, and if someone hacked in and changed the surface finish, where it might look the same to the human eye, but there's a small difference, and it maybe cause it to not behave as good tribologically, then that could be an issue.
Wow, a lot to think about. But it's interesting that this is happening at Auburn. They really have this focus on tribology and manufacturing and the future, just like what I talk about in this podcast, the future of manufacturing and automation and all these complex and exciting things that are going on. And I know that the article I wrote several years ago, we did focus on how this tribology program is helping to close the manufacturing skills gap.
Mm-hmm.
I've been talking about this for over a decade. We've been talking about this skills gap where these veterans of the industry are retiring, and then the new guys coming up, the recent graduates, the talented and smart students that you're putting out into the workforce. There is a skills gap there. These young guys are very tech savvy, and the older veterans are more hands-on and have, all these great sensory skills and knowledge that they're going to take with them. But this program does help close that gap a little bit. So can you talk about that?
Yeah, that center I mentioned, the Interdisciplinary Center for Advanced Manufacturing, their main goal, I think, is really education. They set up a small plant, and I think you can actually hire them to make things. Mm-hmm. So if you're in the Auburn area and you need to make something, you could contact them. But part of that is then they're going to teach people, some students, but also people from the community, how to use some of the newer technologies, newer machines. That's the main goal of that center.
Yeah, it's really, really interesting. And the students who are in it are really excited about manufacturing jobs. Most of them are engineers, but some of them are learning a little bit more trade skills. And I just think it's fascinating that it's such a robust program.
I think we saw that with the pandemic. Maybe that's one good thing that came from all this is when our supply chain got interrupted and we stopped getting toilet paper or whatever. Everything's got to be made. And
that's right.
It's very important. There's a lot of technical and engineering and science that goes into making all these things. And
yes, absolutely. We've also learned how to use more automation through the pandemic because maybe everyone couldn't be in the manufacturing facility and had to work remotely. And
that's a good point.
We've really sharpened our skills, and whether we wanted to or not, we were forced to. You have to embrace technology at some point.
Yeah, I mean, I know, and this has been going for a little while, but a lot of these plants can monitor, their machines, their systems remotely.
That's right. I mean, it's big, especially now. I mean, it was already on the forefront, but now I think the pandemic has forced us to really embrace that even more so. I think that's something that all manufacturers are having to look at, whether they were before or not. As we talk about the future of manufacturing, which is what we talk about in every episode of this podcast, how do you feel about companies out there? Do you think they're effectively preparing for the future?
I always try to keep in touch, going to, I haven't been able to go as many conferences this year because of everything, but,
Right, of course.
And talk to people. I hope so. I think it all depends on the industry. Some industries do seem to kind of get, for whatever reason, maybe they don't have enough extra time and resources to move things forward, while other industries are really pushing things forward. And I think that's part of the reason that center is there is if you don't have the resources to do it, they're trying to help.
If you're getting calls from companies saying, I'm interested in one of your students who has some special knowledge about tribology, then yes, they're preparing for the future.
Yeah. Yeah.
I mean, that's certainly
great,
an indication that they are.
Yeah. And by the way, we're always trying to arrange internships. So if anybody who's listening and is interested in interning our students, feel free to contact us.
That's great. And I'll put some contact information in the show notes. People can reach out to you. That would be great. Rob, this has really been fun. I always enjoy talking to you because I always learn something new every time I do. And I just really want to thank you for being here and sharing your knowledge and helping us to understand a little bit more about tribology and how important it is to manufacturing. But I want to give you the last word. So is there anything else you want to say or want to tell us about what you're seeing as the future of manufacturing and how tribology fits into this?
I hope people realize that there's a lot of value here that they could take advantage of. 20 to 30% of all the energy man makes is lost to friction. And then if you look at how things break and wear out, the most common mechanism of failure is wear, just things wearing out. And so by caring about some of these things and looking into it, we can make big steps forward into making improvements in the way we do things. Friction in tribology really depends on everything. It depends on the environment, humidity, you're in a salt environment, temperature, the materials. So what I'm saying is small changes can make a big difference in the way the machines work. And keeping things clean. I hear a lot of people in the industry professing about making sure that the lubricants they use are taken care of well and are replaced and are stored in a clean environment, and you're filtering the oil. So there's a lot of things like that too that can make a big difference.
That's really interesting. I love talking to you about this. Thank you so much for sharing all this with our listeners.
Thank you for having me on.
This brings us to the end of the show. Thank you so much for listening. Please do me a favor and subscribe, rate, and review the podcast on iTunes. If you have interesting information to share and want to contact me about being a guest on a future episode of this podcast, please send me an email at michelle@navigatecontent.com. You can also send me questions that I will have my expert guests answer for you on a future episode. And in the meantime, please check out my book series on modern manufacturing to read more than 30 real-world case studies about how global companies are using smart technology and innovation to build the factory of the future. All the links to the books and articles mentioned in this podcast are in the show notes. Have a great week, and please join me for the next episode of Factory of the Future.